Hello everyone, welcome to my channel, and this is Rick Loresto. I am a circuit builder, and we have here in the house my idol diode gone wild. Hello, hello. You were telling me we're going to analyze some circuits here. A resistor, dimmer, circuit. I think we have three circuits here. And there is the resistor, dimmer, circuit here. This is LED and resistor. I think this is not a resistor dimmer switch. Because how can I make this LED dim? There's no circuit here or switch or some sort of mechanism to control this LED. I think this is just a regular LED circuit. You build this LED circuit, very simple. Why don't you just buy it in the Amazon or in the Google or in the eBay? It's very simple. In here, we have a circuit here is a group of LED. Yellow, red, green. 6 pieces. And how can I make this a dimmer circuit? There is no control mechanism here. So this is not a dimmer circuit. I think this is just a multiple LED color used in a Christmas tree during Christmas season. Here we have another circuit here. I think this one is the LED resistor dimmer circuit because there is an LED resistor and I think this is the dimmer. This one. I think this is variable resistor. So we know that this is the resistor dimmer circuit. It's so simple. Why don't you just buy that in the online, in the Amazon or in the eBay? It is a garbage circuit, very simple. Are you kidding me, guys? Even a kid can be done or can be made this kind of circuit. See, this is sort of very old technology. Using a turning knob of a radio station. This is turning knob. Okay, since I'm a guest here, we're going to analyze the circuit for you. Where is the circuit diagram here? So let us get the circuit diagram of this circuits. The circuit diagram of this simple circuit is this LED circuit. We have voltage supply, switch, resistor, and LED. It's so simple. This LED is connected in resistor and it light because of the voltage supply here. And this is our previous circuit. And we calculated all the values here. Also layout here. Very simple. I don't build a simple circuit. I am a high-tech. Where is the circuit here? Group of LED. Let us see the circuit diagram. So this is also a previous circuit. It is LED series circuit. That is the previous circuit name. We have voltage supply and a group of LED in series. It's very simple. Just like you connect the LED in series and it's like this. Yellow, green, red. So I'm interested in this resistor dimmer circuit. Let us see the circuit. Where is the circuit diagram? Here. We have here a resistor dimmer circuit. So This is the diagram. We have 12-volt supply, switch, resistor, LED, and you call this a variable resistor. You see the symbol with an arrow, and it has a ohms rating or resistance value of 0 to 250 kilo ohms. So that is the circuit diagram of this. This is our dimmer circuit. So what's in here? What's are going to calculate here with that circuit? So in here, this is from this circuit, LED circuit, and you just put a variable resistor here in the side. See the diagram and the diagram of this previous circuit. You just put a variable resistor here, variable resistor. That is the difference. We're just putting that in the LED circuit of this. So let's analyze the circuit here. When you close the switch, current flows here to the resistor, LED, and variable resistor to the ground. So there is a confusion here. What is the direction of the current here? There is no an arrow. So let us first check the given here. We have here voltage supply 12 volts. We have the resistor of 1 kilo ohms. So we have a value of resistor here 1 kilo ohms, because we already solved that in a previous circuit. And the diode here 2 volts turn on. That is the voltage rating of the diode. It means it should be 2 volts to make the LED to light or to turn on. Some using this as a term such as forward voltage. Here 0.02 ampere and a turn on current of the LED. It means in order to turn on the LED, you need 2 volts here and a current of 0.02 ampere. That is the current rating of the LED. And sometimes the genius people use this forward current rating of the LED, IF. What's new here? We have voltage supply here, PS. What's that? So in here 0.02, which is also equal to, that is the diode rating in ampere or current. Here you are having 20 milliampere. Since that is the current rating, we're going to the milli here is just like times 10 to negative 3 and also equal to 0.32 ampere. We're just converting 20 milliampere to 0.02 ampere. As simple as that. And we have BS. So BS here is called voltage source. Sometimes they call voltage supply or power source or power supply. There's so many terms used here with this BS. Why I call it voltage source or voltage supply. So this one LED and this one is a voltage supply. So in here we have the symbol for variable resistor. This one, that's the symbol. See, we have resistance of 0 to 250 kilo ohms. And this symbol has an arrow here crossing into the resistor symbol. So it means it's variable. That's why they call it variable resistor. And what is this? We also have here variable resistor, sometimes called potentiometer, rheostat, or trim pot. Rheostat is term used in radio or in communication. Potentiometer for the electronics technician, and trim pot for the electronics hobbyist. But here we're using variable resistor. That is variable resistor, or also trim pot, or potentiometer, or rheostat, whatever you call it. And that is the symbol here. You turn the knob clockwise. See, 0 to 250K. And the resistance is going up. That's going up when you turn the knob clockwise from starting position 0 here. So this is turn knob type of variable resistor, very old fashioned. So what is this? So in here we have a situation here that if the variable resistor is equal to 0, now it's equal to 0 ohms, because initially we set it to 0 ohms. So that's why it's look like this. Still the LED is lighting here. So we are using a formula here, Kirchhoff's voltage law. We have here excuse, voltage supply minus the voltage drop of each load. So this is the load. This is a voltage supply here. That's why we have voltage supply minus the voltage drop resistor, voltage drop of diode, voltage drop of the variable resistor. So it means voltage supply is minusing or subtracting it to resistor, LED, variable resistor. Very simple formula by Kirchhoff's. And substitution, since the voltage rating of the LED is 2 volts, it means this is 2 volts. Why? Because it is turns on. And we know voltage rating of LED turns on is 2 volts. That is the standard calculation of calculating this type of LED. So we got now here, and since the value of the resistor variable is 0, means there's a 0 voltage here, almost a short here, because it has 0 resistance. That's our initial resistance value of this variable resistor. So we got now here, what is this? At KBL sign technique. We have a sign technique here to solve this problem. So here, you are always asking where the current flows. And here's one of the technique, a sign technique. Just follow the sign. In here, we have here negative to positive voltage supply. And since the resistor is opposing the current here, so it should be plus, minus. Also in the LED, plus, minus. Plus anode, minus cathode. And then plus, minus, variable resistor. So, when you connect the resistor in series, the resistor has polarity. It means the resistor is polarized in the circuit, or it has polarity with plus or minus when you connect it in the circuit. So it means resistor has polarity in this design. So in here, sign technique, you just follow the sign here. Minus, voltage supply. Plus, voltage supply, resistor, plus voltage drop at the diode, plus voltage drop at the variable resistor. So we got here minus, plus, plus, plus. That is Kirchhoff's voltage law equals 0. The sum of all voltages in a closed loop is equal to 0. Substitution, we got 10 volts. What's the difference with this formula? This is a standard formula used by all of us. It's simply supply voltage minus the voltage drop across the load. But in here, it's negative BS plus BS minus plus BR minus BR. Here, the technique here is the standard supply load technique. And here, we are using a sign technique. Just follow the sign. See? Negative BS plus BR plus BD plus BRB is equal to 0. That is KBL. By using mathematical equation, transposition to the left and to the right, we also have this equation. Negative transposing to the right, positive. Positive transposing to the left, negative. But here, we're just transposing here. B to the left, to the right becomes plus. This BD become minus. When you're transposing it here, the sign will change. That's the mathematical and here, what we have here, it seems we are get lost here. So, let us use other technique here. You're asking me where the current flows also? It also flows here. When you follow the sign technique, plus, minus, minus, minus. So, it's the same as this standard technique. Supply minus the load. This technique, sign technique. We have two sign technique. From here and also here. Just follow the sign. So that is the meaning of this equation. So we got now here the same. Let us have some situation here. If variable resistance is 250 kilo ohms, it means we're turning the knob to 250 kilo ohms. Change it to 250. By turning it to 250, let us turn it. So this is 0. Where is that? I can see that here. Turn it clockwise. Oh, it's getting dim. See? But it's still a little light here. Not fully dim, but it's turned off. What's wrong? What happened to the circuit? Let us explain that. So when you turn the knob, the given is only a voltage supply here. And we know the resistance value. External resistance here, and we have now the new value of variable resistor 250. So it's now 250 LED 1 kilo ohms in voltage supply. Using Ohm's law, the sum of all resistance in series is equal to the total resistance. RT is equal to R plus RB. It means according to ohms, we're going to add all the resistance since we are in a series circuit. Resistance here and here is equal to the total resistance in a circuit. So we have 1 kilo ohms plus 250 kilo ohms. And simplifying that, we got 251 kilo ohms. Using Ohm's law again, voltage supply is equal to total voltage, 12 volts. Using Ohm's law, since we know the total resistance, so the current in the circuit now is 0.000478 ampere. So it means the current flowing here now, since our variable resistor value is 250 kiloohms, is 0.0004. The current now flowing is 0.0004. When you turn the turning knob of this variable resistor, and here LED voltage drop, and we have here internal resistance of the diode is 100 ohms. What makes this internal resistance of the diode here as 100 ohms? So let us just analyze this. There is certain internal resistance of this LED, and we already computed that with our LED series circuit, because the sum of all the voltages here is 2 volts, because they're in series, voltage is divided. Here we calculated that voltage supply 12 volts divided by the current here is 0.02 ampere, because all the LED here in series is turning on. It means two of each LED is receiving 2 volts here. That's why it's 0.02. Current in series is constant. This is our previous circuit. And we have here 600 ohms. 12 divided by 0.02. That is the internal resistance of each LED. I mean the total resistance of all the LED here. Since they are 6, divided by 6, it becomes 100 ohms. So it means LED has internal resistance of 100 ohms. Since our total current is the current flowing now in the circuit, which is getting the LED is turning off. So calculating the voltage drop of the LED here. So there's a voltage drop at LED here. Just only this. Since the current here constant 0.004, we get a voltage drop here of 0.004. Since the voltage rating of LED to turn on is 0.02, it means this voltage rating, voltage drop here is not enough to turn on the LED. And also the current of the diode rating is the total current. That is the new current flows. And we got the LED to turn on. The current rating of diode should be 0.02 ampere, but here it's 0.0004. Still there is a little light here. It's not completely turning off, and total current flows here is 0.0004, not enough to turn on this LED. And then also the voltage here is just 0.004. So this LED will not turning on, since all the current is dissipated here at the variable resistance, very big resistance, 250 kilo ohms, but still the circuit is flowing here. But the LED is not turning on because the voltage rating of LED is 2 volts. That's why when you turn it back, LED turns on because it receives 2 volts. And the current now in the circuit is 0.02 ampere. But if you see, that's a simple resistor dimmer circuit, using resistor to make the LED dim, to make a resistor dimmer circuit. And thank you for watching the video. Bye bye.